Fellow Pokeprofs, Hyokul is one of the toughest Pokemon to ever exist. It has a higher defense than every other Pokemon, legendaries included, except for Eternamax Eternatus. Just how tough is Hyokul Shell? The answer is not very. Let me explain. Toughness, strength, and hardness are terms that tend to be used interchangeably. However, in engineering and material science, these are vastly different and depend on how the material is made. Hardness refers to a material's ability to resist deformation or indentation. This property is typically measured by pressing a hard object, such as a diamond, into the material and measuring the force required to make an indentation. A material that is very hard will require a lot of force to make an indentation. Strength, on the other hand, refers to a material's ability to resist breaking, cracking, or permanently deforming under applied forces. This property is typically measured by applying a force to a sample of the material until it breaks or deforms. Finally, toughness refers to a material's ability to absorb energy without fracturing. A material that is very tough can withstand impacts or sudden forces without breaking or shattering. For example, in general, glass is brittle, which is to say that it is not tough. This means it does not easily deform. However, it is hard and strong, meaning it can withstand a lot of force before breaking. Rubber might not be very hard, but can be easily deformed, so it can be very tough and absorb a lot of energy without permanently deforming or breaking. Steel, like glass, is both hard and strong. Depending on the way it is manufactured, however, it may not be very tough, so it may break easily under sudden impacts, especially in cold temperatures. That's partly what led to the Titanic sinking. In this video, we'll explore what hardness is and how it is measured. Finally, Hyokul Shell will be put to the test against the strongest attack from the strongest Pokemon. Let's look at some definitions. Firstly, what is hardness exactly? It is a measure of how easy it is to scratch something. The scratch doesn't have to be visible to the naked eye, but it is useful to be able to compare the hardness of different materials without having to use expensive equipment like microscopes. This is the Mohs scale. It was created by this person in 1812. The scale is based on the ability of mineral A to scratch mineral B visibly. The scale consists of 10 minerals arranged in order of increasing hardness. Diamond is the hardest material on Earth. This means that it is nearly impossible to scratch. That's why drill bits are sometimes coated or even made entirely out of diamond. If you drill through hard materials, you'd better have something harder to drill with otherwise. Material A can only scratch material B if material A is harder. This is why you can scratch an itch more effectively with your fingernails. If something is not hard, it is soft. Ice cream is soft because you can easily scoop it with a spoon even if you just took it out of the freezer. The Mohs scale is good, but it would be even better if we could get some more meaningful numbers. We want to be able to calculate the hardness of materials. Enter the Vickers hardness test. The Vickers hardness test is one way to measure how hard a material is. It works by pressing a diamond tip into the material and measuring the depth of the indentation. Remember, nothing is harder than diamond. If nothing is harder than diamond, how do you measure the hardness of diamond? I said earlier that material A can only scratch material B if material A is harder. But this is not completely true. Material A can be the same hardness as material B. It basically means that the sample will be scratched by the indenter and the indenter will be scratched by the sample because they are both made of the same material. However, if there are impurities in the sample, this will make the sample softer. The higher the quality of the sample, the fewer the impurities and the higher the hardness. How would we measure the hardness of Hyoku shell using the Vickers hardness test? First, let's break off a tiny sample of it and place it under a microscope. Then, we'll apply a diamond tip, which looks like a square-based pyramid with an angle of 136 degrees between opposite faces with a known force for 10 or 15 seconds. The size of the resulting impression will be measured using the microscope, and the Vickers hardness number can be calculated using this formula, where F is the force the indenter applied in newtons and D is the average length of the diagonals left in the surface of the sample by the indenter. HV is the Vickers hardness number and is measured in newtons per millimeter squared, which is the same as gigapascals. Diamond has a hardness value of 100 gigapascals. For reference, steel has a hardness of 8 gigapascals. There are different methods of empirically measuring hardness today, such as Brinell, Rockwell, and Buchholz. But the Vickers test is the most recognized. Several factors can change the observed hardness of a material. For example, how quickly the force from the indenter is applied, how long it is applied for, and how much force is applied. Even the thickness of the material being tested also has to be considered. Now that we know all this, let's try and calculate the hardness of Hyoku shell, shall we? Would you look at that? Our work here is done before it had even begun. If Hyoku shell is vase-like, then Hyoku shell must be made of a kind of ceramic. What is the hardest ceramic? Cubic boron nitride. According to several review articles, this is the hardest ceramic. Depending on how it's created, it can even champion the hardness of diamond. Ceramics are like a ginormous jigsaw puzzle, with each tiny piece aligned and interlocked with its neighbors to create a solid structure. You can often differentiate between a jigsaw and a regular picture because the jigsaw tends to have all these spaces in between the individual pieces. These spaces reduce the integrity of a ceramic. But if the jigsaw pieces are small enough, several mechanical properties such as the hardness can be increased. This is known as the Hall-Petch relationship. As D, the size of the jigsaw piece, more commonly known as the grain size, decreases, HV, which in this case is the hardness, increases. 4 nanometers is about the size that achieves the highest hardness. This means that for Hyoku shell to be as hard as feasibly possible, the grains that make up a shell must be extremely small. Smaller than that. Even smaller. Smaller still. Okay, not that small. There is a limit to how small the grain size can be before the hardness starts to decrease again, due to the mobility of dislocations, but that's beyond the scope of this video. Hyoku shell can't just be made of CBN this small though, otherwise its shell would be transparent. Nature doesn't tend to optimize for the best anyway. Therefore, let's say the shell is mostly made of CBN with grains about 1,000 times bigger, with intermittent grains of 4 nanometers. Nature. Is boron nitride a natural organic material? The answer is yes. Boron nitride has been found in trace amounts in a mineral found only in the Earth's mantle called kingsongite. Perhaps in the Pokemon world, kingsongite is much more common, or maybe Hyokle has evolved to synthesize its own CBN. Either way, let's just say that Hyokle shell is as hard as diamond, based on what I said earlier. How much force could it withstand before it breaks? No, wait. That would be asking about its strength, which we don't want to do right now. How much force could it withstand before it gets scratched? In other words, how powerful must the attack be for Hyokle to even notice, assuming it's completely protected in its shell? The most powerful move is called Explosion, and the Pokemon with the greatest attack that can use this move is Mega Metagross at level 100. Hyokle ironically has the lowest attack of all Pokemon. That doesn't matter if Hyokle can simply hide in its shell, or does it? Explosion is a move so powerful that it causes the user to faint. When Mega Metagross faints, it becomes regular Metagross again. So let's suppose that it converted its entire mass into energy with, say, 90% efficiency, because it's that amazing. Using E equals mc squared, with m being the difference in mass between Mega Metagross and regular Metagross, and c squared being the speed of light squared, the energy for Mega Metagross's explosion would be equivalent to about 8 billion tons of TNT, which is equivalent to all the energy the entire Earth receives from the sun in 90 seconds. Or the amount of energy that the US uses in 4 years, or that the UK uses in 60. Obviously, this energy goes out in all directions. So to find out how much energy actually lands on Hyokle, we need to use the equation for flux density. I will assume that r, the distance between both Pokemon, is 10 meters, and that the efficiency of this process is also 90%. Using the formula for the area of an ellipse, I worked out the cross-sectional area for Hyokle shell to be 0.0375 meters squared, according to my Blender model. We can use this equation to work out that the amount of energy landing on Hyokle shell is about 40,000 times smaller than the total radiant energy released from Mega Metagross. Again, from 10 meters away, and over the area the size of a salad plate, lands enough energy to power all the homes of the entire United States of America for half an hour. With this number, we can now work out force thanks to this equation. Let's say that Hyokle is fixed in place. Okay, combining the equations for work done and Vicker's hardness, we would find the indentation distance to be 1.2 meters. Hyokle can't actually be fixed in place, of course. Hyokle shell won't just get a scratch. It won't just crack. Hyokle, along with its shell, will be disintegrated. Goodbye, Hyokle. How did you find that? Indeed, there is no known material that can withstand any force. Let me know in the comments below what you learned, and if there's a topic you'd like me to talk about next. I release a video every month or so. If you appreciate the effort I put into making this video, please like and subscribe. PokeProfs, continue evolving!